Download this code from codegive.com, link in the description below. Troubleshooting connection lost, error 13, with socket.io, a comprehensive guide. The dreaded connection lost, often manifesting as error 13 or similar variations, when using socket.io is a common yet frustrating issue. It signifies a disruption in the persistent connection between the socket.io client, typically in a web browser, and the socket.io server. This tutorial dives deep into the possible causes, troubleshooting steps, and preventative measures, complete with code examples. Understanding the basics. Before tackling the problem, let's quickly recap the socket.io architecture. *socket.io server, node.js. This is your backend server, running on node.js, or other supported platforms, that manages the WebSocket connections with clients. It handles the logic for sending and receiving real-time data. *socket.io client, web browser, mobile app. This is the JavaScript library embedded in your client-side application, web browser, mobile app, that establishes and maintains a connection to the socket.io server. Underlying transport. Socket.io abstracts away the underlying transport mechanism. It tries to use WebSocket first. If WebSocket fails, it falls back to other techniques like long polling. This fallback mechanism can sometimes contribute to disconnection issues. Common causes of connection lost, error 13. 1. Network instability. Client-side intermittent Wi-Fi connections, mobile network fluctuations, or other network disruptions on the client's end. Server-side network issues on the server, overloaded server resources, or misconfigured network settings. Intermediate network devices. Firewalls, proxies, load balancers, and VPNs can interfere with the connection by closing idle connections, dropping packets, or having incompatible configurations. 2. Server overload/resource exhaustion. CPU bottleneck. The server might be overwhelmed by the number of connected clients or the computational intensity of the data processing. Memory exhaustion. The server runs out of memory, leading to crashes and connection drops. File descriptors. The server might exceed the maximum number of file descriptors allowed by the operating system, preventing it from accepting new connections or maintaining existing ones. 3. Firewall/proxy interference. Idle connection timeout. Firewalls and proxies often have timeouts that automatically close connections that have been idle for a certain period. This is a common culprit. WebSocket blocking. Some firewalls or proxies may be configured to block WebSocket connections entirely, forcing socket.io to fall back to less efficient transports, long polling, which are more prone to disconnect ions. Incorrect configuration. Misconfigured proxy settings can prevent the WebSocket handshake from completing successfully. 4. Keep alive issues. Missing or incorrect configuration. If the keep alive mechanism, pings and pongs, between the client and server isn't properly configured, idle connections might be prematurely terminated. Transport layer problems. The underlying transport layer, example TCP, might have issues with keep alive mechanisms, leading to connection drops. 5. Client-side disconnect ions. Browser tab closed/refreshed. The user might accidentally close the browser tab or refresh the page, terminating the connection. Client-side code errors. An error in the client-side JavaScript code could trigger an unexpected disconnection. Network errors. The client side might not get any internet connection, after which a disconnect might happen. 6. Server-side errors. Asterisk unhandled exceptions. Asterisk uncaught exceptions in your server-side socket.io event handlers can crash the server or cause it to temporarily become unresponsive, leading to connection drops. Asterisk server restarts / deployments. Asterisk server restarts or deployments can abruptly terminate all existing connections. Asterisk database errors. Asterisk if your socket.io logic depends on a database, errors in the database interaction can cause the server to crash or become unresponsive. 7 socket.io configuration issues. Asterisk ping timeout and ping interval. Asterisk incorrectly configured ping timeout and ping interval options can lead to premature disconnect ions if the server doesn't receive a ping from the client within the specified timeout. Asterisk transports. Asterisk forcing only WebSocket as the transport when some clients may not support it can result in connection failures. Asterisk cores, cross-origin resource sharing. If your server and client are running on different domains, you need to configure cores correctly to allow the client to connect to the server. 8 version incompatibilities. Asterisk mismatched socket.io client and server versions. Asterisk using incompatible versions of the socket.io client and server libraries can lead to unexpected behavior, including connection drops. Troubleshooting steps. 1. Examine logs, client and server. Client-side logs, browser console. Open the browser's developer console, usually by pressing F12, and look for error messages, warnings, or console.log statements that indicate the cause of the disconnection. Specifically, look for messages from the socket.io client library. Server-side logs. Inspect your server-side logs, usually written to a file or the console, for error messages, exceptions, or warnings related to socket.io. Pay close attention to timestamps to correlate them with the client-side disconnection events. The disconnect event on both client and server provides a reason parameter that can be invaluable in diagnosing the problem. *IO server disconnect, the server initiated the disconnect. Look for errors or server-side logic that might be triggering this. *IO client disconnect, the client initiated the disconnect, example the user closed the tab. *ping timeout, the server didn't receive a ping from the client within the ping timeout period. *transport close, the underlying transport, WebSocket or HTTP long polling, was closed. This could indicate network issues or firewall interference. Transport error, an error occurred with the underlying transport. 2. Check network connectivity. Client side. Try accessing other websites to ensure the client has a working internet connection. Check Wi-Fi or mobile network signal strength. Test the connection using ping or trace route to your server, if you have that capability. Server side. Use ping or trace route to test connectivity to external websites and to ensure the server can reach the internet. Check the server's network configuration, example firewall rules, routing tables. 3. Investigate firewall/proxy settings. Client side. Temporarily disable any firewalls or proxy settings on the client machine to see if they are interfering with the connection. Warning: this is only for testing and should be re-enabled afterward. Server side. Examine the firewall rules on the server and any intermediate network devices to ensure that WebSocket connections, typically on port 443 for WSS, are allowed. Check the proxy server configuration to ensure that it supports WebSockets and that the WebSocket upgrade handshake is being handled correctly. You may need to configure the proxy to explicitly forward WebSocket connections to the socket.io server. Look for options like proxy_pass or similar settings. Example, Inks reverse proxy for socket.io, WebSocket support. Explanation *** proxy _HTTP version 1.1, essential for WebSocket support. * proxy _set header upgrade $HTTP upgrade, passes the upgrade header to the upstream server, signaling a WebSocket upgrade request. * proxy _set header connection upgrade, sets the connection header to upgrade to complete the WebSocket handshake. * proxy _set header host, pass the original host header through to the upstream server. For monitor server resources *CPU usage *use tools like top, or your server monitoring system to check the CPU utilization of the node.js process running your socket.io server. High CPU usage can indicate a performance bottleneck. Memory usage monitor the memory usage of the node.js process. Memory leaks or excessive memory consumption can lead to crashes and connection drops. File descriptors use lsof PPID, replace PID with the process ID of your node.js server, to check the number of open file descriptors. If the number is approaching the system limit, you may need to increase the limit, usually through ulimit n on Linux/Mac OS. Network IO monitor the network traffic to and from the server. High network traffic can also indicate a potential bottleneck. 5. Adjust socket.io configuration *** ping timeout and ping interval ** adjust these values to fine-tune the keep alive mechanism. A larger ping timeout might be necessary for clients with unreliable network connections. However, setting it too high will make the server take longer to detect a truly dead connection. Example transports allows socket.io to automatically negotiate the best transport method. Avoid forcing only WebSocket unless you are absolutely sure that all clients support it. CORS configuration make sure your CORS configuration is correct. In production, you should specify the exact origin of your client applications, rather than using *, which allows all origins. 6. Implement reconnection logic * client-side automatic reconnection * socket.io client has built-in reconnection feature. By default, reconnection is true, so, when connection is lost, it will automatically try to reconnect. However, you can configure its parameters. Example graceful handling on the server * when a client disconnects, clean up any resources associated with that client to prevent memory leaks. 7. Update socket.io libraries * ensure that you are using the latest stable versions of the socket.io client and server libraries. Outdated versions may contain bugs or compatibility issues that can cause connection problems. 8. Code review ** carefully review your server-side socket.io event handlers for any potential errors, unhandled exceptions, or inefficient code that could be contributing to server overload. Use try-catch blocks to handle potential exceptions gracefully. 9. Load testing ** perform load testing on your socket.io server to simulate a large number of concurrent connections and message exchanges. This can help you identify performance bottlenecks and areas where your server needs to be optimized. Tools like Artillery or Apache Bench can be used for load testing. Example scenario and solution * Scenario * clients are frequently disconnecting with a ping timeout reason. Possible cause * the ping timeout is too low for clients with unreliable network connections. Solution * 1. Increase ping timeout * increase the ping timeout value in your socket.io server configuration. 2. Monitor network conditions * investigate the network conditions of the clients that are experiencing the timeouts. Are they using unreliable Wi-Fi or mobile networks? If so, you may need to provide them with guidance on improving their network connectivity. 3. Client-side debugging * implement more detailed logging on the client side to gather more information about the network conditions at the time of the disconnection. In summary, troubleshooting connection lost, error 13, with socket.io requires a systematic approach *. Start with the logs * client-side and server-side logs are your best friend. Check the network * connectivity issues are a common cause. Monitor server resources * overloaded servers are prone to disconnect ions. Fine-tune socket.io configuration * ping timeout, ping interval, and transports can significantly impact connection stability. Implement reconnection logic * provide a seamless user experience when disconnect ions occur. Don't forget firewalls and proxies * ensure they are configured correctly to support websockets. Keep your libraries up to date * use the latest stable versions. By following these steps, you can diagnose and resolve most connection lost issues in your socket.io applications. Remember to tailor your troubleshooting efforts to the specific context of your application and network environment. Good luck.